I hope that you can see those two images in the same graphical window, and we run the reorientation of the bottom image, because we want to reorient our anatomical image to better align it with the top canonical average structural image. So we click on current image to reorient it, and we see on the left the interactive menu with many different options. Right, forward and up are for X, Y and Z coordinates, and pitch, roll and yaw for respective rotations. In the presentation I already propose some values to be entered in those fields, but you can do it independently. How to do the reorientation? Very easy. You just place your cursor in the field and you type whatever you want. For example, I want to move it 40 millimeters right. The displacement are in millimeters. Just for example, I enter 40 and press enter. Now you see it is very much on the right. But it is better that we if we enter negative value, minus 40, it's going to be displaced to the left. Okay, but in fact we need just another very important option. When you press right click on the image and you press on millimeter in coordinates, you will get a possibility to pick the current coordinate, and you can pick just 0, 0, 0 to go to AC point. Okay, now you are at AC of the top image. For the bottom image, you need to move a little bit on the left, minus 5. Well, actually, this is too much. I think 0 will be quite well. Again, here you don't have to be very precise. You just have to put it approximately in the same space. A little bit forward, and for sure we need some pitch. It's in radians. 1 radian is about 60 degrees, so there will be fractions of radians normally. And some roll, you see, it is turned in this direction a bit, so we must compensate and to roll it anti-clockwise. Minus 0, 0, 5. Okay. If you finished with the reorientations, you want to apply those modifications. At this step, you don't change the data. Very important to keep it in mind. But you change the header of the data. The structure of the brain is the same. The values of each voxel are the same. But the coordinates of the voxels will be systematically changed if you press apply to images.
Володя, мы плохо видим координаты. Да, можно немножко увеличить. Ну, зум использовать.
Сейчас. Right, forward, up, pitch, roll, yaw, and resize. We don't do any resize. And at the end you have to click on apply to images. There will be a menu where you can pick the images where you apply your reorientation. And at the moment only one image is selected. Which is just structural. We manipulated only structural image, and now we reorient only structural image. Okay? So we just press done. They ask if we save reorientation matrix for future reference. You click yes. This is the file name. It is quite okay. We press save. And now the structural image is reoriented. But now we have to do the same. If you don't mind, I stop the modifier. And we do exactly the same with our functional. Now the first image you select is the structural one, the very same you have already reoriented. And after you select functional, then you apply some displacement rotation on your functional, but not just one. All the list of the functional files you have in your functional folder, and then you have to get something like this. Pretty well fitted functional to the structural. And the structural, if you remember, is already correct, reoriented pretty correctly, respectively to the canonical image. Let's do it. We click check reg. We select structural, and we select the very first functional, and we click done. You see two images, and it is very obvious, even without reorientation, without the contours, that the orientation is different for those two images. Now you have to change the position and orientation of this image so that it fits this one. Now you click on the image you want to reorient. You select Reorient Images, Current Image. You get the contours and the reorientation parameters. You have to move the functional image down, enter -35 backward. For moving forward you enter positive values, for moving backward negative values, and you move it down, also -35 millimeters, and you need quite some pitch, +0.1. Still not enough. We can add more. And perhaps not so much forward. -30. Or even -25. More pitch. A bit up. Yes, it is different than what I've done before. Don't know why, but according to the image, it is more or less okay. And now you can apply the parameters to all the functional images. So in this menu, you right click on the list and you click select all, and there must be '84 files. And you press done, and you save reorientation matrix. It saves it in the same folder where all the functionals are located. It's pretty fast, and now, according to our plan, we can go to automatic realignment. But before, I propose you once again to check the orientation of your data. Now we select 3 files: the canonical image, canonical structural, our image, and the first functional, and the structural. You see 3 images at the same time, and now you can put the contours of one of them, for example structural. If you pick reorient image, current image, on the others, and you can navigate.
So can you repeat what is
Let's repeat it again. Check range. From the previous folders you go to canonical, you pick average 351. Then from the same menu previous, it's very useful because MATLAB remembers which folder did you use before. You go to functional, you select the first functional, and then you go to structural and you select the first structural. 3 files are selected and 3 files will be displayed for check their registration. Done. 3 images. And you can see, even without any contours, that they are oriented approximately in the same way. And this is quite enough for us. We can move forward. Since that point, almost everything will be done automatically by the software. But if your images are too far apart and too far from the canonical image, the automatical procedures can pretty probably fail. We don't want it. But now it's okay. And we do realignment. First I show you what we are going to do in the presentation, and then we go to SPM and I will do exactly what I have shown. So this is the second step, realignment. This is the button for alignment. You select realign, estimate and reslice. You highlight data, select new session, and then inside this new session you select files and you select all the functional files. This is the filter you can apply, but at the moment you don't need any filter. You just select all the files. There must be 84 files. Then you press reslice images and reslice options and pick just the mean image to be resliced. And at the end you save the job in a separate folder that you call jobs, and you call it realign, and then you run. What is reslicing and why is it important to keep in mind if you reslice or not? Reslice, unlike reorient, is going to change your data. It is going to interpolate reoriented data so that the planes of acquisition are parallel to the horizontal plane. At the moment, as you can clearly see, they are not parallel, but we can reslice them if we need. It helps a bit to coregistration, but it is going to reduce a bit the quality of your data. In the manual, it is recommended that we do reslice just for mean image, and the mean image will be used later for coregistration. What is the mean image? The mean image will be the average of all functional scans after they are realigned. And what is the realignment itself? Realignment is the same as what we have done just a few minutes before. It is the change of orientation of the data between the functional scans. Why do we need it? We need it because during the scanning session, inside the scanner, unintentionally, the subject can and most likely will move. This motion is not very big. It is just a few millimeters or less. But for the functional neuroimage, even this small displacement or rotation is critical, because it creates enormously strong artifacts at the border between the gray matter and CSF. CSF is brightly colored in the functional scan, and the gray matter is much more dark. So if something that in this particular voxel has been dark tones bright, the software perceives it as an activation, which is obviously an artifact and is very harmful for estimation of the real activation. That's why the software will reorient slightly all the 84 or whatever is the number of scans so that they fit precisely each other, and it will generate the data array of the motion parameters. This is what you are going to see at the end of this module. So in the data, you create new session, and inside the session you select the files. You go to functional and you select all, and you select this means that you select 84 files. You click done, and you don't change most of the default parameters. In the resliced images, you select just the mean image, not all images, mean image only. That's all. Just don't forget to save your data, your job or batch. It is a synonymous name for the M file, a MATLAB file, where all the parameters of the processing are stored. Why it is useful? I will show you. So we call it Realign.
Володя, увеличьте, пожалуйста, очень плохо видно.
Okay. Realign. We save it in the folder jobs. Realign. It is a mat file. You can call it whatever you want. And actually, it is not absolutely necessary that you save it, but it is better to save it. You click Save, and now you just close the window of Batch Editor as if you never opened it. Now, what you can do if you want to run the processing you have decided before. You click on batch or batch. Actually, it is batch. You go to file, you load batch or job, it is the same. You go to folder jobs and you select the file created before, Realign, and you press done. And here you have all the parameters set before. So if you want to repeat your analysis, it is very easy. And if you want to figure out what exactly has been done during different steps of the processing and analysis, you just go to the folder where you store all your jobs, and you see and read, and you can always repeat the analysis or repeat it with some modifications if you need. It is extremely useful to save every step, and you can do it. So now, if everything is ready like this, the only thing you have to do is to press run. And we press run. It's going to take some time, but not very long, for the software to estimate the orientation parameters. Typically you have to see this kind of progress indicator in your interactive window of SPM. Those are the parameters of the displacement and rotation estimated by the software, and they are plotted against images. As you can see, the total displacement is less than 1 millimeter, which means that the subject was very stable. He didn't move a lot, but still there was some motion in the y-axis, which means that the subject gradually moved in the direction of the feet. Well, maybe not the whole subject, but the head of the subject, for sure. And there were some rotations. The next step, yes, it's quite the same as what is expected. This means that we go in the right direction. Oh, I'm sorry. The next step is coregistration. Coregistration is about the same idea as realignment, but with some features. In particular, realignment deals with the images of the same modality. For example, a lot of functional scans. Coregistration aligns two images of different modalities. For example, and this is what we are going to do, the functional and the structural. So we are going to highlight the reference image and select the mean functional image. which is the result of the previous step of preprocessing. And the source image, which is the image that will be reoriented, will be the structural image. We will try to fit the location of the structural image to the average functional image. That's all. Then we have to save the job and to run it. Let's go and do it in SPM. We pick Coregister, estimate, we select reference image, which is in the folder of functional images, and it starts from mean. So it is very easy to find it in the long list if we type in the filter window mean dot star. Now we have just one file here, very easy to select. You select it, and you press done. And the source image is the structural image. This is the image we need. We select it, we press done, and don't forget to save the job. You save it to folder jobs, and you call it whatever you prefer, but logical to call it Coregister. It is saved.
Володя,
And now we can run it. Yes?
трошки не встигаємо.
Не встигаємо. Добре.
Докажіть, що не встигаємо.